Hello everyone, myself Brajan Vaishya. Welcome back to our second video. In the first video, we studied the nomenclature of the coordination compound. In today's video, we'll try to find out what is the hybridization of the coordination compound. Actually, the hybridization, the whole concept is governed by the valence bond theory. To understand this, we need to follow three basic rules. Number one, we have a good idea about the electronic configuration of the central metal atom from 21 to 30. As we can easily remember, there's a trick. Science teacher, very cruel, mange fair copy, nikle copper chin. Number two, the spectrochemical series. There are some ligand which can be considered as strong field ligand and others are known as weak field ligand. Strong field ligand always love to pair and commonly known as low spin complex. Weak field ligand, they do not love to pair and commonly known as the high spin complex. And the third, so quite simple, we should have a basic idea about the coordination number. If the coordination number is 6, then it could be from D2sp3 or sp3d2. D2sp3 means the inner orbital complex and sp3d2 means the outer orbital complex. So we need to know the electronic configuration of the transition elements starting from 21 to 30, right? So 21 stands for scandium, 22 for titanium, 23 for vanadium, 24 it's chromium, like that it goes on, 30 for zinc. So it's a very simple trick. I already mentioned that scandium stands for science, titanium stands for teacher, vanadium stands for very, chromium stands for cruel. So science teacher, very cruel, mange fair copy, nikle copper zinc. So the first alphabet or 1 to 3 letter, it will be equivalent to the element. So like that, scandium 21. See the outermost electronic configuration, that's 4s2 and 3d1. Titanium, it's 4s2 3d2. So it continues, but we have a special look at the chromium. Chromium, it's not as we expect, it should be 4s2 and 3d4, but it is 4s1 and 3d5 because 3d5 is the stable configuration. Like that, the copper, we expect it should be 4s2 and 3d9, but it is actually 4s1 and 3d10 because d4 which is missing and d9 which is missing is a very unstable configuration, so they do not exist, right? Because the nearest configuration 3d5 and 3d10 is most stable one. Then guys, second one, we have to remember a spectrochemical series. Spectrochemical start from iodide up to carbonyl. So from iodide to water, they are weak field ligand. It's basically a table we have to remember. And thiocyanate to N to carbonyl, they are known as strong field ligand. Fine. So I have divided it into categories like weak or strong field ligand. Why? Because strong field ligand is a low spin complex and they love to pair because of low crystal field splitting energy. Similarly, weak field ligand, it is a high spin complex and they do not love to pair crystal field splitting energy. Now guys, what is spin actually? So let me take an example. Suppose this is D5. 1, 2, 3, 4, 5. There are 5 electrons in the D. So spin value is half into 5. Why? Because it's an everything 1, 2, 3, 4, 5. Half into 5, it is 2 half. So the value is 2 half. Similarly, D5, if the configuration is like that, top spin, top, bottom, and again top. The spin value is half minus half. This half stands for the top spin, minus half stands for the bottom spin. So plus half minus half cancel out. Like that, we have the final value of half. So guys, 2 half, it is a high spin complex. Half, it is a low spin complex. Fine. The next, we need to know the denticity of the ligand because we have to find out the coordination number. See, look at this. This is unidentate ligand. So I have mentioned few ligand here like halide, cyanide, nitro, it's amide. All the elements, all the ligands, they have a coordination number of 1. So it is unidentate ligand. So coordination number is 1. Bidentate ligand, it is a bidentate ligand. See, look at this. This is ethane 1,2 diene, commonly known as EN. EN. So what is the structure? NH2, CH2, CH2, NH2. So both are the nitrogen. They have a lone pair, so they can donate. So this ethylene diamine can donate electron pair from both the nitrogen. So it is a bidentate. One ligand is itself to donate 2 electron pair. So guys, this is known as bidentate. I have given few examples like oxalate, acetyl acetantone, like that. Again, if we come to the third one, it is tridentate ligand. So let's take an example. This is diene, diethylene triamine. So NH2, NH, NH2. There are 3 nitrogen atoms bonded with 2 ethylene groups. So it is diethylene. So 3 nitrogen, 3 electron pair. So one single diene itself capable of donating 3 pair of electrons. So it is tridentate. Like that, tetradentate. So tetradentate, we have an example of nitroloacetatone, right? Number 5, it is pentadentate ligand. Pentadentate ligand, if we take an example, the name is ethylene diamine triacetate. So see guys, this is 2 nitrogen because of the amine, 2 hydrogen, 2 carbon, ethylene, and the group 1, 2, 3. So CH2 COO negative, negative. So guys, 1, 2 and 3, 4 and 5. So one single ethylene diamine triacetate can donate 5 pair of electron, 5 pair of electron. So it is a pentadentate ligand. So the coordination number of this ligand is 5. The last one, it is a hexadentate ligand and commonly known as ethylene diamine tetraacetate. Tetra, okay. Earlier one was tri, so it is tetra. Tetra means, look at the structure. 2 nitrogen, CH2 negative, CH2CO negative, 1, 2, 3, 4, 5, 6. 6 pair of electron donation. So it is known as hexadentate ligand. Thank you. There are 2 types of hybridization in our syllabus. Number 1 is coordination number 6. So coordination number 6, D2sp3, which is commonly known as inner orbital complex, and other possibilities is sp3d2, which is known as outer orbital complex. As you can see, the coordination number 6, there are 2 possibilities and the shape is octahedral. There are 6 ligand and this is a central metal atom like a 6 head. So it is octahedral complex. I have given few examples here. The first case. So this is our first complex, CrNH3 whole 6, 3 positive. First, coordination number. Check the coordination number. It is 1 into 6 equal to 6. Why it is 1? Because NH3, amine is unidentate ligand. See, look at this. Unidentate ligand, amine, NH3. So, there is only 1 pair of electron donation. First step, we will write the electronic configuration from Aufbau principle. Chromium, which is atomic number is 24, and this is the electronic configuration according to Aufbau principle. See, we already had a look, right? This is the thing. First step, then see 5 electron in 3d orbital, 1, 2, 3, 4, 5. 4s, there is 1 electron. Then we'll find the oxidation state. Oxidation state, chromium X, it is a neutral ligand, so 0 equal to 3, X equal to 3, oxidation state is 3. So now the chromium will lose 3 electron. So how? 1 electron, 2 and 3, these 3 will be lost. Cr3 positive, the remaining configuration is argon 3d3. So 1 electron from 4s1, 2 electron from 3d5. So final configuration is 3d3. This is the representation 1, 2, 3. So guys, now we can see there are 1, 2, 3, 4, 5, 6. There are 6 pair of empty orbital. See. So this 6 pair of empty orbital will be fulfilled by the amine. And amine is a monodentate ligand. So since amine is a monodentate ligand, only it can donate 1 pair of electron. There will be 6 pair. So 1, 2, 3, 4, 5, 6. 6 pair will be donation. So hybridization will be C, D2S1 P3. So D2sp3 is the hybridization, and because of the presence of unpaired electron, it is the magnetic behavior is paramagnetic, and this is the magnetic moment formula, under root of n into n plus 2, n equal to 3. Here n equal to 3 because 3 pair of unpaired electron, we have 3.86. Now guys, the second one, Fe(F6) whole 3 negative. Let's try to find out the hybridization. This is a coordination number 6 because the halide, we already know halide X negative is a unidentate ligand. Oxidation state, see, equal to 3. Fine. So we'll write the electronic configuration of iron, that is Ar3d6 4s2. Because of the oxidation state, it will lost 3 electron, 2 from 4s, 1 from 3d. So it would be argon 3d5. So this is the configuration, 3d5, 1 2 3 4 5. This is 3d, right? 3d, 4s, 4p, and this is 4d. Now F, fluorine, is a weak field ligand. So because it is a weak field ligand, it cannot pair. We already studied, see, weak field ligand, and this is the fluorine, because we already studied I negative to what, it is a weak field ligand. Weak field ligand do not love to pair. So there were enough opportunities, but because of weak field nature, it cannot pair. So the remaining orbital will be sp3d2, and we have 6 electron pair from fluorine, 6 pair of electrons from fluoride. So the hybridization is sp3d2, right? And this is outer orbital configuration. Now the second part, if we have a coordination number 4, so there are 2 possibilities, one is dsp2 and the other is sp3. So we have a look for coordination number sp3. It is tetrahedral in nature, given some examples. dsp2, this is square planar. I have given few examples. So guys, let's take an example. NiCN4 whole 2 positive. Coordination number is 4 because of cyanide. We already know cyanide is a monodentate ligand or unidentate ligand. So coordination number is 1 into 4 equal to 4. Nickel, the atomic number is 28. We'll write the electronic configuration. Then the oxidation state. What is the oxidation state of this particular state? Because of this, it will lost 2 electrons. So oxidation state will be 2, Ni2 plus. So 2 electron will be lost by 4s2. See, this 2 electron is out. So now we have this configuration 3d8. 8 electron, 1 2 3 4 5 6 7 8. But we know Cn is a strong field ligand, so it would love to pair. We already studied, see, strong field ligand, it is from low spin complex and love to pair. See, cyanide is this thing, up to this they strong field ligand. So this electron will come and join as a pair. So now the remaining slot are, there will be one d orbital because it is 3d, so one is empty slot, then this one and this 2. Why we have taken 4? Because the coordination number is 4. The cyanide will come and the hybridization will be dsp2. One is from d, s, then p. And presence of fully paired electron, there is no unpaired electron, the magnetic moment is diamagnetic, and the magnetic moment mu will be equal to 0 because n equal to 0. Similarly, we have the last one, NiCO4. The coordination number is 4, oxidation state is 0 because of carbonyl, and CO is a neutral ligand. Nickel, the atomic number is 28. This is the configuration. The oxidation state is 0, so Ni0 has the same oxidation state. 3d8 4s2, there are 3d8 electrons, 4s2 electron. So guys, now we found that carbonyl is a very strong field ligand. See, in fact this is the most strongest one, strong field ligand, carbonyl. And strong field ligand always love to pair. See, so these 2 electron will come, and we have an empty slot in S. So we have an empty slot of orbital 4s, then 4p. So this 3 plus 1 4 orbital, empty orbital, filled up by the carbonyl ligand, which is a monodentate ligand. So it will give only one pair of electron. So 1 2 3 4. The hybridization is sp3. Fully paired, so it is diamagnetic. Shape is tetrahedral, diamagnetic, and magnetic moment is 0. So we are going to sum up the video here. Hope it is fruitful for you guys. I have mentioned the link in the comment section for the detailed notes. Please go through it. Thank you. Keep in touch.